So in this video, we will put in numbers into the equilibrium constant utilizing the law of mass action. The law of mass action tells us that the equilibrium constant, when the reaction is over and settled with, is going to be products over reactants, each raised to the stoichiometric coefficient. So here we have Kc, the C stands for concentration, though we have gases here, so the gases can also be expressed as a pressure. So remember, gases can be pressure or concentration. And so products over reactants, we got our concentrations here. So the equilibrium expression here is going to be a little bit different for part A because it's going to be NH3 squared, the concentration of which, divided by the concentration of H2 cubed times the concentration of N2 raised to the power of 1. So it's going to be 0.25, and we don't have to worry about units, so that's a 1 relief here. H2 is cubed. Its concentration according to the problem is 1.91. Concentration of N2 here is 0.11. All right, so we're going to do this in our calculator and see what we get. Okay, divide that by, so 1.91, we can raise it to the power of 3. So to the power of 3 times 0.11. So we'll close those parentheses. And getting an answer about 0.0815 as our equilibrium constant. So 8.12 times 10 to the, or 8.15 times 10 to the minus 2. So this reaction shown here actually favors the reactant side, right? So it's not a very large number. In fact, it's a small number. So what about part B? So we can do the exact same thing, raising everything to the appropriate powers. But one thing, if you notice what we've done between A and B, we basically multiplied this whole equation through by 1/2 to get to the reaction that we see in part B. So if we multiply everything through by 1/2 in an equation, the equilibrium constant gets raised to the 1/2 power. So multiply everything out, the equilibrium constant gets raised to that number that we multiplied everything out. So the difference between A and B is we multiplied it by 1/2. So what we're going to do here for part B is raise this to the 1/2, and that will be our answer. Also, 1/2 is the same thing as square root. And let's do our square root button, which is this one over here. Square root of our answer. And I'm getting about 0.285. Now we could also do this another way, utilizing a law of mass action. The Kc here is going to be, so the products over reactants, remember. So our Kc is going to be the concentration of NH3 divided by the concentration of N2 raised to the 1/2 power. So this can be a little bit hard to do on your calculator, though it's entirely possible to do it, times the concentration of H2 raised to the power of 3/2. So if we can put in our numbers here, we should get the same thing. So 0.25 is our concentration of NH3 divided by N2 raised to the 1/2 power times the concentration of H2, and this one's raised to the 3/2 power, okay, 1.91. So as we can see here, we should get the same answer here first. So square root of 0.11, okay, times 1.91 to the power of 3/2. So 3/2 is the same thing as 1.5. Okay, divide this by 0.25, and then we're going to flip it, do the 1 over x, flipping it, and we get 0.285, yep, which is pretty much the same thing as we got if we just take the square root of the original Kc for the reaction. So there's multiple ways to solve for this. So the easiest way is realizing, again, as a review, we multiplied the whole reaction by 1/2. So we take that Kc and raise it to the 1/2, which is in other words, square rooting it.